Okay, hello everyone. My name is Sverre Brandsberg. I'm part of the Azure Global Energy team here at Microsoft, and it's my pleasure to welcome you all to this session here at the Research Summit, where we're going to talk about advanced carbon capture and energy management. So the topic of energy management and carbon capture, they're huge, and there's no way we can sort of give them justice here in these sessions that we have. And I will try to provide a little bit of framing before we enter into these amazing panels that we have managed to put together for you all for this session. So I think before we dive into this, the one piece that I'd like to tell our customers, my colleagues, and everyone I talk to on this topic is how energy is implicitly linked to societal progress. And I think from a bit of a simplistic lens, you can say that access to energy also defines your level of access to energy defines also how developed a nation can be, and sort of the pursuit of energy has been relentless for humankind through history. And I think we're now in a time period where we're starting to see that also that pursuit has had consequences that we might not have realized when certain things were put in motion. And CO2 levels in the atmosphere, global warming, and all this. Now we're living the consequences of this. So a great way of looking at this, in my mind, is this pie chart that we're seeing right here. And it basically shows that, if you're going to address the emissions problem, you have to address the energy problem as well. So they inexplicably linked, both in cause and solution. And I think you then also have the dimension here of, the different degrees of development across the world. So some countries are, highly developed, others are still developing. We can't look at this through, one lens. We have to cover all of these aspects. And I think that's, again, the complexity and the excitement of this topic, and why we need great technology solutions to help, get us out of this track we're in and tackle this emissions problem and get to a net zero future here, 20 years out or 20 to 30 years out or so. I'll also say it's geopolitical, so there is that angle here as well, and there's not any one company can do, but we are really working hard with our energy customers and throwing all the resources we have at it to tackle this problem and get us down to net zero. So in a summary for our strategy for this, you see that if you start from the left here, it says renewable energy. I think that is on everyone's mind. We need to up the investments there. We need to get that capacity up. We need to get countries that need access to energy to start with renewable, not go down the hydrocarbon-based route that some of the developed world has relied on for a long time. We need to work on efficient operations, and we need, the sum of this is that we will get to a clean energy future. The two topics that we have picked for the panel discussions here at the summit is really related to the two left columns. So on the renewable side, it's about how we can integrate renewables into the grid. There are lots of technical challenges there that you will hear a panel of worldwide academic experts and industry leaders talk about. And the topic we picked for efficient operations is really around carbon management, or how we can collect carbon and safely take it out of the system so that we over time can reduce the concentration of CO2 in the atmosphere and get the sort of these warming trends hopefully under control. So before we move into this, I again would like to thank all of these amazing people that we have managed to collect that have agreed to come and talk to us or talk to all of you today. And I wish all of you a sort of amazing journey through both the energy optimization, energy efficiency track and the carbon sequestration track that we will move into now. So thank you so much. Hello everyone, my name is Sverre Brandsberg, and I'm part of the Azure Global Energy team here at Microsoft. It's my pleasure to welcome all of you, a truly worldwide audience today, and this great panel to this session around CCS, and we'll get into what that is. So we have an amazing collection of industry leaders and experts from academia, and I'm confident that all of you will know a lot more about this topic once you exit this session than when we now are kicking it off. So let me do a quick introduction of the panelists. We have Dr. Rohit Singh, who is the Senior Vice President of Renewables and Low Carbon Technologies at Equinor. So thank you for being here. Then we have Professor Felix Herrmann from Georgia Tech University. And finally, Darryl Willis, who is the CVP for Energy and Sustainability here at Microsoft. So I said we're here to talk about CCS, carbon capture, sequestration, storage. I think there are many names or sort of words that are used in that sequence. And you sometimes also hear about CCUS, which is the utilization of the carbon dioxide. And I think you can see this in context of renewable, recycling, and energy transition in that sense. But in a nutshell, CCS is the term we will use today to talk about the process of capturing CO2 directly from air or from exhaust gases and then storing it or sequestering it for a very, very long time so that it no longer acts as a greenhouse gas in the atmosphere. This is a complicated process. It involves multiple steps and process steps and actors, industry actors, etc., etc. And if we're here thinking of industrial sources of emissions, it can be a power plant, it can be some kind of smokestack that we see on the horizon when we're out and about. There are pipelines, infrastructure for collection, transportation, and eventually long-term storage that tends to be in a geological formation. That's why also the sequester term comes in. So in the subsurface, CCS aims to permanently and safely store the CO2 so that it's taken out of the atmosphere where it's interacting and sort of helping with or influencing the temperature rise that we're seeing. So separately, I would say we know how to effectively run every single step of this process, of the CCS process. But we are here today talking about how to make the end-to-end process efficient, scalable, reliable, and highlighting that is a big challenge, and also pursuing sort of ideas and angles for how a company like Microsoft can help facilitate this technology and make it scale and get it out there in action. I will end by saying that CCS in itself is not a panacea for climate change. It is one of the tools, I would say it's one of the key tools at our disposal to go after this problem. And I think we have, as I said, some of the world's leading experts here today to help address, put some light on this challenge that we have in front of us. So with that, I think we'll dive into the topic, and I'll ask Rohit to maybe comment a little bit on main trends, sort of opportunities and technology challenges that you see from the industry perspective around CCS. So Rohit.
Yeah, thanks, Sverre, for that introduction. So it's a complex topic, but let me start by saying that the energy transition in front of us, and reducing the worst impacts of climate change require almost everything we have in our arsenal. CCS is one of them. And what we also see now is that beyond generating electricity and power from renewable sources, we also have to think about removing carbon from the atmosphere. So when we are looking at the whole portfolio of what we need to do, it becomes quite an important component of society's response. And then you kind of ask the big question, is that, how much can you lock away? How much can you actually lock away? And what's interesting is that the theoretical potential of how much we can lock away is absolutely huge. It's in teratons. So it is potentially of the size of scale that you're looking for. But of course, it doesn't come for free. And that's where some of the biggest challenges, like in all technologies in general, there is a challenge of getting sufficient scale so that you can drive costs down. And that's really, I think, where the main technical challenges is in some sense. On one hand, they are about driving cost to a point where it's essentially, if you think about it, unless you're doing something with the carbon that you're capturing, which is you're selling for some other product, it is a waste management business. So the lower cost you can make it, the better it is. So that's kind of one component of the challenge there. The second component of the challenge is, can you prove that it stays safely locked away? So that's kind of the two angles to look at this problem from, and I think that's where I would kind of frame it from. when you look at the chain of technologies involved, from when you capture the carbon to when you lock it into the reservoir, what you also notice is that the capture cost tends to be quite high. So obviously there is an expectation that technology and innovation drive that cost down over a period of time. It's not to say that storage and transport are solved. Well, they are also areas where we expect a lot of innovation to take place. But the dominant cost still comes from the capture part. The aspect of transporting carbon dioxide, whether it's in pipelines or ships and so on, has its own subtle, interesting things, which I think many of us will find quite interesting. First of all, you have to deal with many phases of carbon dioxide. It could be in solid, it can be liquid, it could be in gaseous form, it could be in critical phase, and often you find a combination of these in these systems that will be eventually what you need to build large-scale CCS work. So that's one interesting aspect of it. Another aspect of it is that when you're actually looking to lock away the gas in underground formations, you have to figure out where to put it, and first of all, and understand that the amount of storage you expect is exactly what is generally what you find, and then, as I mentioned, is there sufficient integrity of the cap rock? So is there sufficient integrity in the structure that you choose to lock it in, that it actually stays where it is. And it is different from oil and gas and water. And so even if oil and gas companies have been trying and actually even have large-scale CCS in operation, the nature of the material is different. So the way it moves around in the subsurface is different. So some of these challenges are actually, I think, quite fascinating. At the same time, if we are able to get a handle on them and really kind of drive the cost and the confidence, cost down and confidence up, we have a massive opportunity in our hands. Maybe Darryl can compliment me on some of the compliment my yeah. Mm-hmm.
Yeah, Rohit, thank you so much. I echo a lot of what you said, and from our perspective at Microsoft, we see stronger climate targets being developed around the world, and increased incentives around these climate targets are injecting new momentum from our perspective in the whole CCS journey. And I think there's a healthy recognition that we cannot achieve net zero as a company, as companies, as countries, or even as the planet by transitioning to renewable energy sources alone. We absolutely have to remove carbon from the atmosphere in order to meet the ambitions around net zero by 2050. And some of the things we're doing at Microsoft in that regard are as follows. One is that everyone's probably heard over the last about 20 months ago or so, we announced our target around being net zero by 2030, which means that we will reduce all of the emissions inside of our company by more than half across our entire business, including our supply chain. Ultimately, we're going to remove more carbon than we emit as a company. But to put a finer point on that, we also said about 20 months ago that by 2050, our goal is to eliminate or remove all of carbon from the environment that we've emitted since Microsoft was founded in 1975 through our electricity consumption in other regards. And I say that to say that these are really bold and big, ambitious targets. And they're going to require us working and partnering with the industry, all industries, in order to get there. In support of that, we've done a few things. We've also recently announced a $1 billion climate investment fund, which is really set up to help us think about how to accelerate the development of carbon reduction, capture, and removal technologies, because a lot of what we'll need in order to make this journey needs to be created. It needs to be invested in a very aggressive way. And finally, as recently as this week, we announced a $100 million commitment to Breakthrough Energy Catalyst, a program that's designed to innovate around direct air capture, around green hydrogen, long-duration energy storage, as well as sustainable aviation fuels. One of the things that is really intriguing to me, and intriguing to us around CCS, is the fact that this capture technology can be retrofitted to existing plants, many of which have recently been built and will probably be operating for decades to come. And I'm also excited we're also excited about the fact that there are tens of facilities that are being created around the world in the area of CCS. And that's been occurring over the course of the last 4 or 5 years in the US, in Europe, and there are also projects that are emerging in places like Australia, China, Korea, the Middle East, and New Zealand. And finally, at the end of the day, the last thing I'll say is that when you think about all of the carbon that needs to be removed by 2050, it seems that roughly something on the order of 10% of it can be delivered. That removal will be or could be delivered by CCS. So this is a must-do, and it's something that is very important to us as a company and as we think about our journey in helping the world deliver on this ambition around net zero.
Yeah, thank you for that, Darryl and Rohit. And I think it's great to hear about what the industry is doing. And I think I'm going to pass it over to Felix here now and get a little bit of the view from the academic side, because I think we can all look at sort of history. If it's energy production or any sort of human progress, it very often plays out as a sort of collaborative effort between industry and academia. And I think it's about how can we work together here in this emerging technology that needs it needs transparency. We need to build trust for the technology in society, etc. And then there are pure technical challenges that will take all the best people we have to crack those. So, Felix, what are your thoughts on that?
Yeah, so a couple of things. I do agree that CCS is really a technology that we should explore to combat climate change. But it's very challenging. And, amongst all the different features that we have to look into, I think it's important that we build a monitoring system, maybe in particular a seismic monitoring system. I'm saying that because we need to really gain the trust of the general public, and we can do that by being very transparent. Why I'm saying that is that if you look, for instance, at geothermal energy, they had a small earthquake in Switzerland that basically stopped the global development of geothermal for a long time, and that keeps me awake at night. So you want to deal with that. Also, after a CCS project is completed, the regulators will have to take it over, and they will have to assume liability, and they want to know what's going on. And so for that, the monitoring system is essential too. And finally, you want to increase the success rates of CCS projects and to optimize the process of the sequestration itself. And for that, a monitoring system can play an important role. The task, though, is massive. It relies on 3D imaging technology that has been used by the oil and gas industry and that has dominated HPC technology for many years, but that's a massive exercise. It also depends on the availability of data sets and compute cycles, because as I mentioned, it's a very computational intensive technology to monitor CO2 and to find out whether there are accidental leaks or compromises of the system. And so and all of this is compounded by the fact that you have to do this monitoring sort of continuous. So just to put things into perspective, if you think about 3D imaging, for those of you who know about neural networks, that is sort of equivalent to running a 10,000 layer convolutional network with about 1 billion features. And you have many of those. So this is a formidable, very large scale computational problem. And the challenges are compounded by the fact that while the oil and gas industry used to have access to their on-premise HPC systems, those golden days are over. So we need to come up with a new way to do that. And one way you could think about that is to create basically a supercomputer for seismic monitoring, sort of modeled along the lines how the OpenAI initiative is constructed. And that will allow academia and startups and others to develop an open source framework for seismic monitoring, also very much like is being done within the OpenAI project. And well, this is open source, so the challenge here is, can we find mechanisms to monetize seismic monitoring algorithms, for instance? So can people in academia fund their students with this? Can startup fund themselves, or can even companies like Microsoft make money out of this? So that goes back to the economic picture that was alluded to before. Now, I'm optimistic that this can work. I was involved in the International Inversion Initiative in Brazil, where the there were tax incentives related to oil and gas production, which led a British gas company to basically build a 70,000 core system for my group and a group at Imperial to develop basically imaging technology for seismic. And that was a fantastic initiative where government incentives by tax, public-private partnership was built to basically develop a technology in collaboration with academics. So that's, I think, a model we should entertain.
Yeah. I think that there are great models that we can sort of look back at that have fostered this sort of public-private partnership and innovation. And I'll ask Rohit to maybe comment a bit on this, because I see Equinor as being leaders in sort of, I would say open source or making data publicly available so that both, academic institutions and NGOs, anyone can see it. So it is about that transparency. So if you could comment maybe a little bit on data and also the sort of potential role of open source, because I think the, oil and gas industry has not been big on open source data. And I think that's sort of why Darryl and myself are here to sort of say, okay, what role can we eventually play there? Is there a room, is there a role to play for open source in this arena going forward?
Yeah, sure, Sarah. So maybe I can let me start a little bit in history. So there is a field west of Norway called Sleipner, and Sleipner has been injecting carbon dioxide and locking it away in an aquifer for 20 plus years now. Now, why is that? And that's a little bit to Felix's point, at least in Norway, the fiscal setup was there that this made business sense. And therefore, such a project was created and a project was executed. And actually, what it resulted in is not only that we got, as a company, got experience of running a large-scale project of this nature, we also got experience. We also got lots of data. So how are the wells doing? What are all the seismic surveys? What about the models and so on? And we decided some years back that this, to be able to actually bring, as again to what Felix was saying, to bring public confidence in the technology that we can actually safely do it, monitor that the carbon dioxide stays where it's supposed to do, we decided to release that data into the open domain for people to work with. And then if I look at the future, when you say, as a company, we also want to make a business out of this, and for it to work, we need it to be adopted. So my belief is that we will take a much more, for the lack of a better word, modern view on it, particularly in the low carbon space, than perhaps what we have seen in an oil and gas type of perspective. And we see that change also in the even in the oil and gas universe. Initiatives like the Open Subsurface Data Universe are really about trying to find common components that don't need to be proprietary, that actually can trigger innovation. And there is I think more and more recognition that these kind of methods and techniques will ultimately be much more beneficial to us than the approaches we've used in the past. So I have little reason to believe that we regress from this type of approach. If anything, I expect to see much more.
Yep. No, it's good to hear these examples from Norway. And Darryl, maybe you can comment a bit on what you're seeing of sort of trends globally, because you visit with most players that are in this field or have ambitions to be in this field. So what are your thoughts or observations from those interactions?
Yes, well, thank you. So we see a couple of things. I think I would probably make three or four brief points. The first one is that most of the executives that I find myself in conversations with around the world are really thinking deeply around what their relationship to a true net zero ambition is. And so I think every C-suite on the planet has a slide that talks about its relationship to ESG and its relationship to what it's doing around the environment and sustainability, but they're trying to really cultivate a much more meaningful relationship. And one of the things, and one of the questions that I continue to get, whether it's a power and utility company, or oil and gas company, or even a mining company, is how can you help us? And what role is there for Microsoft to help us? And we typically have a conversation with them around three things. One is around the fact that we've recently announced our Cloud for Sustainability, which we really think will help every customer do a better job around tracking emissions from all sources and then more importantly, creating a plan to reduce them. We also spend quite a bit of time, get a lot of questions around data that sits on the edge in the well-known space of IoT, and how can IoT and how can data analytics help us? And I think about things we're doing as we work on CCS projects with Equinor and Shell and Total, and we think about how do you track volumes, as an example, from a point of ingestion into a CCS system to really help you better enable the reporting of fugitive and venting emissions at every point along the way. So using IoT platforms is an area where there's a lot of interest and support. And the last thing I would say is that many companies are really thinking more deeply about the fact that they want to focus on what they're good at. They want to focus on what they're good at and saying, in many cases, you know what, we've been managing data centers. We've been doing a lot of things on-prem, and we would rather identify a trusted partner that we can work with who can help us tap into the elasticity of the cloud, as well as do a better job of protecting data. Because at Microsoft, our license to operate is driven by our ability to create space and protection, space for data, but also protection for data. And that's been a really, those are some of the bigger conversations I found myself being involved in over the course of the last 12 to 24 months.
Yeah, no, excellent. And I think you mentioned Cloud for Sustainability, and we also have an initiative called the Planetary Computer that Microsoft has launched. And I'm sort of sitting here wondering if those are the kind of angles that we could take and create sort of an environment for data, to Rohit's point, 20 years of data, it's available. I mean, we're used to maps and satellite images, but what about this kind of data for a research community, for an academic community? But then, you mentioned implicitly platform. You say that they want to get out of the data center business and have tooling. So I'll pivot back to this sort of open source question and sort of put that out to be commented on. What level of investments of sort of common baseline open source functionality would be useful in this space? What would a company like Equinor see that they could use? What would you want to keep for yourself? Is this a path that merits that we put some muscle behind it and try to pursue it?
Yeah, let me try to answer it two ways. One kind of, in general, what we find now, when I'm now stepping out from CCS and looking at how we are looking at technology in general. So when we are looking at technology in general, we are realizing, obviously, that software plays a bigger and bigger role in almost every technology activity that we partake in. And innovation in software increasingly pushes us towards use and reuse of open source. So, one way or the other, we are moving towards more and more open source. Then, when I look at low carbon space, and CCS is one of the topics in there, these are nascent businesses. These are nascent markets, and in a lot of cases, it's not everything is known. And in this case, companies like ours and our peers and so on, we are much more open to reimagining how ecosystems should come together. So I think when I combine those two things, what's happening in the technology trend in general, and what's specific about the low carbon space, and CCS is one of them, what you find is a much more open and permissive discussion around how should we leverage these technologies. So it's much less protectionism than you probably have experienced before, and much more about how do we solve this problem. And I'm very encouraged to see that, and I hope that trend really actually continues.
Okay, that should be music to your ears, Felix, because I think you've been one of the pioneers of open source and also what I would say sort of low code, no code sort of modularization of these toolkits historically from seismic imaging. And how would you want to see this progress in this space, and maybe add some comments on this angle of sort of transparency and trust building for society, because I think that's another sort of important angle here that is different than someone who just pursues, say, a business objective.
Yeah, so look, I agree. I think it's a fantastic candidate for open source, right? Because you guarantee transparency, people can reproduce, you can give people access to technology everywhere and around the world. And my group is developing a software platform to do exactly that, to de-risk basically the development of a seismic monitoring system. The problem is a little bit, though, from an academic perspective, and I know there are initiatives that are basically making open source seismic imaging solutions, where a lot of people still have the attitude, well, thank you very much, it's open source, we take it, and why would we pay for it? And that it goes back to the remark I made earlier, is that we have to really find a model how to fund open source. So for instance, if open source yields that Microsoft can sell a ton of cycles to somebody, then perhaps the people that develop these algorithms should have access to a piece of the pie to pay their students or to pay their summer salary or to provide other incentives, right? So I think that's essential, but it is clear that open source is the way to accelerate innovation. It's the way to give people around the world access to de-risk this technology, to start to do their homework, to convince all the stakeholders and the general public of the safety of this technology. So there's no doubt that that's the way to go.
Hey, Sverre, can I say?
I think maybe there's some homework here for Darryl and myself to think about these vehicles that we have in Microsoft to support these activities. I would also talk about GitHub and other tools that we have in our arsenal here that we could potentially use to facilitate this. And I'll give another plug for this planetary computer, which I think is sort of the right framing for this, because it is about impact to climate change. And as I said, in the introduction, this is one of multiple technologies, but to sort of put it in that context, I think will make this become a known entity for people as the technology matures. So I think moving forward, and we don't have a lot of time for this panel, and also knowing our audience here, we are sort of at the Microsoft Research Summit, and we're talking about an exciting big challenge, and I think that there are some big challenges here, but I'll sort of let all of you comment a little bit of sort of what are some of the key challenges, and maybe a little bit of sort of direct challenges to the audience here, so the MSR community plus, what are some of the things you would like to see activity and pursuit and innovation happen along the horizons related to CCS? So maybe I'll let Rohit kick it off, since you're sitting closest to implementation of this these days.
Yeah, sure. Thanks, Sverre. So, I would have said, even though we didn't spend too much time on the capture part, absolutely fantastic area. And I think, I really encourage people to look into how they could contribute, improving, and, eventually has impact on direct air capture, which has a huge potential. So I think, looking into that, I think is very interesting. Then I think, and I know Felix will cover monitoring, so I'll try to cover a couple of other things. There is something about understanding, before you decide that I'm going to do a CCS project here. It's a very different one from an oil and gas project. Yes, there's many similarities, but the risk profile is different. So how do I get semi-basin scale modeling up with relatively sparse data up front in the thing? And this is referring back to high performance computing, machine learning. What can we do to accelerate our understanding up front, to understand this is actually a good place where we can actually secure a project of a certain size, because scale matters, and scale actually drives down the cost and makes these projects happen. So I think dynamic modeling at a very large scale, super interesting. And I think the other thing I would have said is that when you put the whole system together, the well, the reservoir, and how the fluid moves in it, and how the carbon dioxide is transported to the pipeline. There's something about system architectures and keeping quite a bit of your optionality till you actually fix the project. Again, sounds very similar to oil and gas, but the margins are much smaller. This is a negative margin game in some sense. So how do I get that far more automated? So not take months and years to do this. How do I get it really rich, really fast, really so I can get these projects scaled out? And I'll stop because I know there's plenty more ideas here. So
Darryl, you're smiling now, so I'll let you seem like you have something to add on here, because I know Felix will get into this monitoring piece again, so please.
Right. Thank you, Sverre. I think I'll just kind of reflect at a high level on what's on my mind as I think about the journey we're all on with this in the CCS space. I guess maybe 3 or 4 points. The first one is that going back to something I think Felix said, that this is, or maybe it was Rohit or both, but this is a really big, ambitious journey, and it's not easy. And I think it's important to recognize that this is really, really hard, and that's why it's not been done. That's a high-level point I wanted to make. Sub-bullets under that would be pace matters. I think that the industry has gone from a period where it was big was better, but I think fast is better now. So the pace at which we do things is absolutely essential. The second sub-point is that partnership matters. Industries like Microsoft working with Equinor and working with academia like Felix is absolutely critical. No one will tackle this and solve this alone. So pace matters, partnership matters. The third thing is that openness. I believe openness wins and close loses. No company, no country, no institution, academic institution will be able to solve this on its own. And the last point I wanted to make is that we're trying to do all of this in a context that we don't talk about that much. And Sverre, you made me think about it when you mentioned the planetary computer. And that context is that over the course of the next 30 years, the population on the planet is going to increase from 7.5 billion people to 10 billion people. So there will be 2.5 more billion people who need access to clean energy, who need access to clean water, and who need access to food. So those are big challenges. We're trying to solve some big challenges around CCS, but the planet is continuing to expand and grow, and that's just going to make it even more challenging. So those are the things on my mind as I kind of think about what's in front of us.
Yep, no, very, very, very valid point. So Felix, I think we're down to 3 minutes, so you can round this one out here now, please.
Sure, I will do that. Okay, first, I do talk to world leaders at Georgia Tech in direct air capture. So that's actually quite nice. A large engineering school at Georgia Tech, there are all these collaborations and we talk. So, but let's just go back to what I do, that's seismic monitoring. So I think there's reason to be optimistic, right? An academic group that I've been leading, first in Canada and now in the US, we have been responsible for 10 times improvements in acquisition productivity. That is 10 times cost reduction. That's massive. We have done the same for the computational cost. I feel that with the technologies we have, and we will have in the near future using machine learning, we can easily go 20x or up in cost reductions of seismic monitoring. And the reason we can do this is because universities are very agile. So for instance, we were able to reproduce and build on a modern industry scale imaging technology on a budget of like 1 or 2 million, whereas companies have spent hundreds, even billion, up to $1 billion on developing that technology. So I'm optimistic, but you have to empower universities. Universities have to hire students. Students are not cheap, right? Compute is not cheap. We need access to that. And then I think there are plenty of people interested because we can do something for the good. This is much more interesting than running machine learning on a YouTube video. The problems are fantastic. You help society combat climate change. So I'm optimistic, but we have to find ways how this is being funded, and then faculty will be incentivized. Thanks.
Very good. Now, so as I promised better understanding, and I think that I know I've learned a lot now listening in on this conversation for the last 30 minutes and so I think that if we can help drive understanding and provide the correct incentives for partnerships to go after this problem, that's probably the best angle for us all to take collectively to address this CCS problem, or the CCS challenge is a better term. So with that, I'll thank all of you panelists for spending time with us today. I hope we can get back together and reflect on this and the next steps on this journey at a future time. And thanks again on behalf of Microsoft for participating in this event.
Thanks.
Thank you, sir.
Thank you. Thank you.
Hi, everyone. Welcome to the Microsoft Research Summit panel. I'm Jon Lemmon, Global Power and Utilities Leader for Azure Engineering, and I will be moderating the panel discussion today. And our topic to cover is meeting CO2 emission targets and the role of the grid. A few opening remarks. So countries around the globe have been setting CO2 emission reduction targets to address the impact of climate change. For the U.S., the Biden administration has set a course that looks to achieve net zero CO2 emissions by 2050 for the nation. The path includes targets for 2030 to achieve 50% reductions from 2005 levels and a 2035 target to have a carbon emission-free power sector. So focusing on the power grid, which accounts for about 30% of CO2 emissions, this panel will discuss the potential paths that can lead to deep decarbonation of the grid and the role the grid will have in decarbonizing the energy-intensive sectors as those sectors transition from combustion to electrification. So to join me in this discussion, we have three extraordinary panel members, and I'd like to give a brief introduction to each panel members. So our first panel member, Professor Stan Whittingham from SUNY Binghamton. He's the inventor of the lithium battery, and for that work, he's won the 2019 Nobel Prize winner. Stan, a brief opportunity to give yourself a few words of introduction and current research interests.
Yes, so I'm Stan Whittingham. I'm Professor of Chemistry and Materials Science at Binghamton University, and I'm still very active in improving lithium-ion batteries. We're looking at new anodes, trying to get back to lithium, looking at better cathodes with the goal with the DOE consortium of getting to 500 watt-hours per kilogram. We're also very busy here in the southern tier of New York and trying to build an ecosystem for green energy with a gigafactory under construction, a solar facility also moving into the area.
Wow, thank you very much, Stan. Great to have you. Our next panel member is Professor Arun Majumdar from Stanford University. Arun is the founding director for the U.S. DOE Advanced Research Project Agency, ARPA-E, and was former acting Undersecretary of Energy. Arun is a member of U.S. National Academy of Science, U.S. National Academy of Engineering, and the American Academy of Arts and Science. Arun, great to have you. A chance to give a self-introduction and your current areas of interest.
Well, John, thanks a lot for inviting me and all of us to this panel. First of all, we are very excited at Stanford that we are starting a new school on climate and sustainability. And this is the first school Stanford has started in 73 years. So we are trying to figure out exactly how to do it. But in fact, this is a part of a broader global engagement as well. But the emphasis on climate sustainability is huge. As for my own research, we are looking at greenhouse gas-free hydrogen production as low a cost as possible. We're looking at direct air capture because that's going to be hugely important, and how to make it more energy efficient and reduce the cost. And on the we have a group looking at AI and machine learning to look at climate risk for communities, because I think we have to elevate the issue of adaptation and resilience as much as decarbonization, because we're likely to go beyond 1.5 and perhaps even 2, and trying to understand the climate threats in terms of the statistics of that with the vulnerabilities of local communities. So we're trying to use machine learning to figure out what are the hotspots for climate in the future so that people at the end of the day are not affected. So that's an area that we're sort of exploring right now.
That's super interesting area. So thanks, Arun, for joining today. And our third panel member is Jon Wellinghoff. Jon was appointed as commissioner to the Federal Energy Regulatory Commission, FERC, in 2006, and was appointed to the FERC chairman in 2009 to 2013. Jon is currently the CEO for GridPolicy, and during his time at FERC, he established groundbreaking policy for grid transformation and renewables, smart grid, distribution efficiency, EVs as a form of storage and demand response. Jon, great to have you. A brief intro and some current interest from you.
It's good to be here, John. Thank you very much. Yes, Jon Wellinghoff, CEO of GridPolicy. Also work with a company on the demand side, Voltus, that does distributed energy platforms on the markets, primarily demand response and other distributed energy resources. So some of the things I'm working on, in addition to what I'm working on with Voltus in integrating distributed energy resources into the grid, into the transmission grid, I'm working with a number of large clients on the grid policy side, trying to make the grid more efficient and also more acceptable to integrating renewable energy into that system. There's a large policy initiative right now going on at FERC. It's called an ANOPR, an Advanced Notice of Proposed Rulemaking on transmission planning and cost allocation. I'm very involved in that proceeding. In fact, I'm writing comments for that proceeding currently for a very large client who's an off-taker of over several gigawatts of renewable energy throughout the U.S., and they're very interested in ensuring that interconnection into the transmission system can be done efficiently and cost effectively, and that we have the ability to build out the transmission system that we need to actually decarbonize the grid by 2035. So those are some of the things I'm working on, John.
That's great. Super excited to have you here today, John, and have the three of you panel members together. Really quick to set the stage, because I want to get to the questions. So the goal of the panel is like briefly discussing these kind of potential paths for the grid to meet the 25-30 goals and beyond. Given the tremendous breadth of the options that we could focus on here, where can we actually focus first to have the most impact? And when appropriate, how can data and say new algorithms and AI and reinforced learning be used to accelerate these options? And when I think about the options we have, just break it down into two buckets. There's technology transformation, and then there's policy and market transformation. So around the technology transformation, I don't want, there's a lot of topics: transmission, distribution, renewables, energy storage, data, nuclear, massive CCUS, and direct carbon capture. And if you think about those technologies being successful, what are kind of the policies and market transformations that need to happen? And maybe we may or may not get to this, but if we had a blank sheet of paper in policy, what would be some of the potential paths we could take? And some of the kind of things related around market with prosumers and peer-to-peer kind of markets arising. Are these the kind of next generation markets? And, around regulation and cyber, how do we unlock data, and also how do we secure data as the data is becoming more highly distributed? So just a few kind of areas I think we can cover in these topics. And so let's get to the questions. So my first question is for Arun. And Arun, you've held numerous leadership positions related to energy for the nation. And at RPU fostered this methodology for identifying a problem to solve, the value of that problem, and then the breakthrough technology and science needed to achieve those goals. I'm wondering if you could help set the stage here also. So my question for you is, how would you break down the problem to reach the zero CO2 by 2035 for the power sector? And what are the key areas that you think are where we can make an impact with today's technologies, but where are the other areas to focus that we need transformational technology changes?
First of all, John, let me just applaud the efforts that Microsoft is making to, first of all, make a commitment and following up on that. And we had your Chief Sustainability Environmental Officer, Lucas Jopa, on a dialogue on Stanford campus, obviously on Zoom, and sort of lay out what you guys are planning to do. And it is very impressive. And you're taking a leadership role in the corporate world with potentially broad impact on society. So let me just break it. If you ask me to break it down, I would break it down into three pieces. One is that, and I hate to start as a scientist and engineer, one is accounting. And I think when you're trying to get to zero, you have to sort of look at scope 1, scope 2, scope 3 emissions. And scope 1 and scope 2 are relatively easy. Scope 3 is difficult. And we don't have a mechanism that is agreed upon by everyone to understand what is scope 3 emissions. And this needs science, engineering, and data to be able to do that. So I'm hoping that Microsoft will take the lead on that, because I believe 70 to 75% of your emissions are in scope 3. So this is not just a goal. I'm assuming and I'm hoping that there'll be a research effort inside Microsoft to not only look at scope 3 emissions internally, but also hopefully add and enable and empower others to have a standard of some kind. So that's sort of one. Then, of course, you need new technologies. I mean, I think you are looking at renewable or carbon-free power, not just on a gigawatt hour level annually, but 24/7, right? And so that is going to be very important. And of course, that involves renewables, and involves storage and coordination in the grid, which will require data and cloud services, et cetera. But given where we are and what you want to be eventually, you also need technologies for negative emissions. And that is going to be very important. And, this is still, I would say, early days of that, not just natural climate solutions, which has lots of uncertainty, but also direct air capture and other things, which will help and those are still wide open, because we are at least a factor of 20 away from thermodynamic limit. So there's a lot of room for improvement out there, and there's R&D needed for that. And you're using energy in your buildings and data centers, et cetera. And we had a discussion with Lucas on building, and you're trying to make a LEED rated building, which is terrific. But I would also say that LEED rating is only for the design. It's not for performance, actual real-time performance. And I think this is where Microsoft could play a role, in a leadership role, and actually looking at data and measurement and reporting out the measured performance of these buildings and understanding where the problems are. Because unless you measure, you'll never know. And so I think there's a whole gamut of things. And I would say that this is, while it's a goal that may have come from top down, I think there is also an embracement of the people at Microsoft to do this, to change the behavior, change the approach. So there's an operational part of it, which I think is going to be hugely important. And finally, I would say that your corporate leadership, I know that you're volunteering in SEC disclosures of what your carbon footprint is. I think that's terrific that you're volunteering, because it may become a requirement by SEC to do that. And so I think there is a role that Microsoft can play, not only internally in reducing its carbon footprint, getting it to zero, but it's really empowering people, and I know this is part of your mission statement, and organizations to also become carbon free as zero carbon by 2030, 2035. And these are the early days. So trying to create mechanisms to do that, technologies to do that, policies to do that, I think it's going to be hugely important. So I applaud Microsoft's effort in that.
Yeah, thanks. That's a great answer. Really informative. So getting on kind of these kind of policy changes we talked about. So question for Jon. Under your leadership at FERC, you established, I think, kind of visionary policy towards transforming the grid. At the time, the learning curves for predicting the cost of PV and wind and batteries were pretty uncertain. And now we see renewables, solar, wind, in cases lower than, say, coal-fired generation, or batteries coming down in cost, a 10x from $1,000 to under $100 per watt hour per kg. So what do you think are some of the key requirements that policy would need to cover to adopt a zero emission grid? And how would the finance and market mechanisms need to change to adopt that?
Well, we did certainly see, Jon, at the time I was at FERC, even though the cost curves were uncertain with respect to these technologies, we saw them rapidly changing to the point that we did recognize that there was a great level of certainty that we were on that trajectory. So we did try to at least start some policies, put in place some policies. Order 1000 with respect to transmission planning and cost allocation, Order 845, which related to demand response on the demand side to ensure that consumers with their resources behind the meter could participate in markets, and a number of other orders and regulations that we put in place. But going forward, I think we will need to continue to have those policies evolve. FERC has put in place recently, within the last 2 years, or a year and a half actually, an Order 2222 that relates solely to distributed resources, which I think here's an area where Microsoft can, I think, play a huge role in helping consumers better understand the resources that they have behind the meter, putting in place the software and the data acquisition systems that can coordinate those resources and then help those resources become part of a platform that is aggregated with other resources. Within one of the companies I work with, Voltus, does this exact thing, but I think it can be expanded tremendously across all customer sectors, and that is a platform for consumers to utilize their resources behind the meter. And I'm talking about demand response, that is load flexibility. We're talking about distributed generation. We're talking about on-site storage, and we're talking about EVs as well. All those technologies, utilize them as grid resources, utilizing them as resources to make the grid more stable, more reliable, and a better, more functioning grid to integrate in large levels of renewables, offshore wind, large-scale wind farms, and large-scale solar into the grid in a more reliable, more stable, and rational way. And to do that from a financial structure perspective, as you asked that question, we really need to ensure that these markets financially value these resources behind the grid that consumers have. Again, something that Order 2222 is trying to do, and that order is in its implementation stages right now. I'm involved with a number of clients, helping them with respect to putting together the implementation tariffs that each of the regional markets are to put in place for this, and also expanding those markets. We only have organized independent markets in this country in about 2/3 of the areas of the country. There's really no markets in the southeastern United States, and there's no markets in the West, with the exception of California. Although that's changing in the West, they do have a sort of a market light in part of the West called an energy imbalance market. But we need to expand those wholesale markets everywhere so consumers will have availability to those markets, and those financial values can be available and transparent to consumers so that they can expand those resources to make the grid work more efficiently for the integration of higher levels of low carbon resources.
That's a challenging prospect, but looking at DER, I mean, the grid becoming more highly distributed and utilizing those resources for flexibility is certainly some of that groundbreaking policy around FERC 2222 is certainly geared towards that. Speaking around energy storage, so I have a question for Stan. Microsoft has plans to move to a zero diesel in the next few years. So backup generators wanting to move to something zero emission type goals for backup generations for data centers. And so, of course, people are looking into lithium ion, but, global production capacity for lithium ion is predicted to grow from, say, 300 gigawatt hours in 2018 to over 2 terawatt hours. And much of this capacity, I think, around 70 to 80% is aimed at EVs. And Stan, so given the current lithium technology, which is, as far as I understand, too expensive for durations in grid storage for applications above 4 hours, can lithium ion in its current form ever meet those longer durations in cost and cycle life? And, what are the kind of other viable energy storage candidates that look promising at this point?
So I think one area that is particularly exciting now is the so-called million-mile battery. No one's really going to drive 1,000,000 miles. But if a battery would last that long, then you can think of the vehicles being plugged into the grid at all times when they're not actually being driven on the road. So they'll give better resilience to the grid. They'll also allow the grid to put storage in or take it out whenever they need it. But obviously we'll need the warranties changed on the vehicles. But that's, I think, probably a better option than thinking about batteries as a second life on the grid. But right now, lithium ion is about $100 a kilowatt hour. That's what the auto companies are paying. If we get all the cobalt out, the price could go down lower. But I think a real issue we have to address now is the sustainable production of the lithium ion batteries. According to various producers, it takes between about 50 and 60 kilowatt hours of energy to produce a 1 kilowatt hour battery. A lot of that's in the mining and the processing. So I think we have to look at ways to update that. Maybe AI and a lot of modeling expertise can help us do that. And clearly we need localized supply chains. By localized, I'm talking about like in North America or in Europe, and the Europeans are doing that. It's not clear North America is doing that right now. And that will cut the price down. And I think it depends on the market, how long, how viable lithium ion is for grid storage. Some of the regulations only allow recovery of the cost if it's 4 hours or less. So in some cases it may be economically viable to run it for longer. But I think as the price comes down, if we switch from the oxides to the phosphates, that should help also reduce the price. But I think a lot of people are talking about flow batteries to cut the cost a lot. The big challenge there is flow battery is a chemical plant. A lot of the utilities like to be flexible, they like mobility. And a lot of the present lithium-ion storage systems are in trailers. They can move it around as they have the need. So we had a system in Binghamton. It worked well. Then they found they could make more money in Ohio, so they took it away one night and moved it to Ohio. So I think the opportunities there, and clearly an opportunity is the one you mentioned in large data centers, grid storage, on a small scale, what do you call that? Nanogrids, microgrids, but clearly batteries can do that. And I think exciting there may be some activity in solid-state batteries, where you don't have to worry so much about the temperature of operation of the battery. So a normal grid lithium-ion battery is only about 70% efficient, because more than 20% of the energy is used in air conditioning of the system to keep the battery happy. Because today, lithium-ion batteries like the same conditions as all of us like. Whereas if we go to a solid state, they can run up to 100 degrees Fahrenheit, probably without too much issue at all, and probably somewhat higher. So I think there are plenty of opportunities there. There's lots of research going on. Clearly, there are people are talking about pumped hydro being still a viable option, and maybe hidden away inside mountains, not necessarily on rivers where you have to have dams and things. But I think there are ample options there, and as they become economically viable, they'll go into application.
Yeah, it's just the technology of lithium ion and how it's just progressed, and the cost coming down is just in my mind, it's been a phenomenal journey, and seeing the production capacity come up. I know, Arun, I know you have some have some energy storage kind of things going on also. If you'd like to chime in on some of the things that you've looked at.
Sure. First of all, I just to echo Stan, I mean, I look at lithium ion as the silicon in semiconductors. It's the 800-pound gorilla. It's going to be very hard to beat. And gallium arsenide has made a dent in some niche application, but it's, the bulk of it, the industrial supply chain and everything is in silicon. I think similar lithium ion. Having said that, I think if you look at the grid, let's say you have 80% renewable penetration, you would need on the order of 100 to maybe 150, 200 hours of storage at one shot, maybe used 4 or 5, maybe 10 times, 15 times a year. which requires the capex of storage to be down to about $10 a kilowatt hour. Now, I think lithium-ion battery is going to find it hard to get there, which requires the new R&D to come up with other solutions. And yes, pumped hydro is the cheapest way to do it, and retrofitting dams that are hydroelectric is even cheaper. But I think we do need to look at other electrochemical systems broadly. Also, thermal systems may not be the round-trip efficiency may not be as good, but cost-wise it becomes less, and so there's R&D going on. So I think we have to explore other opportunities for storage as well, for the long-duration storage. And long duration means anything like from 10 hours all the way to 100, 200 hours or so, which maybe, and data centers may be the first market for it, which is terrific to have for those technologies.
Yeah, great. And that's, I wanted to talk a little bit about this idea of using the batteries, because if you think about lithium ion, is at least most of it being geared towards EV production in the next few years. But Jon, as as FERC chairman, you had a very progressive view on EVs playing a role in energy storage. I think I read somewhere you had this term called the cashback card. And I was wondering, I think maybe back in that time, there were some technology requirements were lacking to have this idea. I remember there was a couple startups about, that looked into, say, leasing out EVs that could be plugged into the grid. I was wondering, where do you think, are we ready for that kind of policy? Or are we ready for this kind of using EVs to stabilize the grid? Is this something that's coming around the corner, or what's your thoughts on that now?
Well, I thought it was coming around the corner 10 years ago, and it hasn't yet, unfortunately. We actually did a very interesting demonstration at FERC in 2007, over 10 years ago. We had an EV at that time, was a converted Honda Scion or a Toyota Scion that was converted by the University of Delaware, Willis to an EV, and he drove it down to Washington, D.C., drove it into the FERC driveway. We hooked it up, plugged it in to an electric meter that we had geared up outside the driveway there, and we then had a engineer from PGM, the independent grid operator in the Mid-Atlantic area, there with his laptop that he was connected wirelessly back to his control room in Pennsylvania, where he could see regulation frequency resources that PGM would use to regulate frequency on the grid. And one of the resources he saw was this 19 kilowatt hour Scion, and he pinged it, and we saw the meter go one way, and he pinged it again, and we saw the meter go the other way. So he actually in real time was using that automobile, that electric vehicle, to provide frequency regulation for the grid. So we demonstrated the concept there at FERC for, publicly for the first time. But unfortunately, we haven't seen the either market rules or the technology keep up with that idea. I think it's all here. I think the components are here. I think initially there was a great reluctance in the part of the auto manufacturers to make their vehicles two-way so that they could in fact push power out to the grid as well as take power in for a number of reasons, but that's changing. You see the new Ford F-150, for example, is going to have that capability. I think the Leaf potentially has that capability, and so a number of other manufacturers are understanding that they can use these vehicles for something more than simply driving people around, because let's face it, those vehicles are going to be parked 80-90% of the time, and if you can park them, plug them in, and you can actually make money by doing that, you can drive down the cost of the EVs. You can also drive down the effective cost of the batteries. You talk about $100 a kilowatt hour for lithium ion now. Arun was talking about having to drive it down to 10 to have effective storage for the grid. But if that battery is being used for multiple purposes, one is that the homeowner or owner of those vehicles or fleet owner, whoever it may be, is buying the vehicle for transportation, but they're also using the vehicle for grid support, then you're effectively driving down that cost of that battery for using it for that grid support purpose. So I think all the components are there, but we really still need to drive the markets and the market structures, hopefully through Order 2222 that does include specifically setting up markets for EVs. And so we're in the process of doing that right now. And then we also need, from a technological standpoint, the manufacturers to get on board to ensure that they're enabling their vehicles to be able to do this.
Yeah, it's super interesting. And I think when we talk too, we always, the levelized cost of the system, and that, battery prices are coming down, but then there's the actual, right, how do you monetize, say, the actual power electronics, the converters and things like that. And that idea of using it for grid storage is kind of monetize that in a second value stream.
So John, maybe an area where this is particularly relevant are school buses. Use an hour or so in the morning, an hour or so late afternoon, and sit idle the rest of the day.
Yeah, fleet vehicle applications is where you can have a time schedule. You take out the stochastic nature of what's going on with the vehicle. And then it brings me, we're starting to run out of time. We have a few minutes left, but I wanted to ask a couple more questions. One, Arun, so if you think about these EV batteries being everywhere, this is truly like the most highly distributed system you can think of. And you were one of the founders of Stanford's initiative, Bits and Watts, back in the day, was really looking at, hey, how do you digitize, information and energy, so to say. It really focused around utilizing distributed energy resources. So what do you think about this idea? I mean, this is the most highly distributed system you can maybe think of.
So the grid is basically about roughly 100 years old. The architecture and the paradigm, not the devices, but the paradigm, is still in the Tesla Edison architecture mode. And so one-way centralized generation, one-way power flow, and that's how the institutions like FERC and utilities and utility, sort of regulatory structure has been formed around this paradigm. This is going through a once-in-a-century massive transformation with distributed energy resources, et cetera. And I think, now that, we still run the grid on 60 hertz balancing, which is a proxy for, imbalance between the generation and the load. But now with distributed energy resources, we need much more higher fidelity of the information where that is, right? And so I think the idea of leveraging the Internet of Things model and the cloud orchestration layer of coordinating all of this so as to provide the services for the grid when you have fluctuation in the renewables and you have services that people, consumers need, that orchestration layer is going to be very important, which will likely be cloud-based and thereby more secure than other things. But I think what is, and John, of course, said so eloquently about the need for new market structures on the market, on the wholesale market side. But what is really important as well is to look at the business models and the regulatory frameworks of the utilities that are responsible for delivering the electricity, because their business model has to change. And I think that is something that we have to do it on a state-by-state basis in the United States. And I think people in Europe and other parts of Australia and all have realized that that is so important, but that is still to be done. And because that, we don't want that to be the barrier for these distributed energy resources and integration of that onto the grid.
Great. Yeah. I think that's so important. And when we've been talking about energy storage, I just want to ask, I mean, having Stan here, Nobel Prize winner, I got to ask you this question, Stan. Your initial chemistry back in the day was lithium metal. You mentioned that lithium metal offers us a wide, it has the best voltage, the highest voltage, and then at the highest, some of the highest energy capacity on the periodic table. So, and that's becoming a hot topic. Are we going to get there? Is it promising? Is lithium metal going to make it? Will it overtake lithium ion?
The answer is yes. It will take time. Exxon did start with lithium metal, but our commercial products, in fact, use a lithium aluminum alloy because we recognize the issue with dendrites. So we have a major effort in the Battery 500 consortium to go back to lithium metal. We're using organic electrolytes, but I think the really exciting area is going to solid state electrolytes and then using lithium metal against those. And I think that, the Blue Solutions batteries are on the market now using polymer. They had a wave of action maybe 15, 20 years ago in the US, had major fire problems. But now they're alive and well in Europe. They're on the grid. Mercedes is putting them in their buses, and they're using lithium metal. So I think lithium metal is coming back. Whether things like silicon will be an intermediate, I'm not sure. They're extremely reactive. But as we use all these fancier systems, we need much better, I would say, computer involvement. Artificial intelligence tells us how best to charge them. Do we do it slow, then fast? Do we do it pulse? And we need a lot more in the way of smart meters telling us when to use everything in our house at what time and when to charge our vehicles and so on and so forth. So it needs a much smarter approach than we've been used to using in the past. But I think we're going to go to lithium metal. You'll see them on the market probably in the next 5 years. All the large auto companies are investing heavily into the 3 or 4 solid state battery companies in this country.
Yeah, it is certainly one of the hottest areas, in the research literature, and I think it's great to see that happening. I just have time for one last question, Jon. Arun mentioned the orchestration of data, like leveraging. We're going to have petabytes of data coming in, and say in this kind of grid transformation. What do you see a role for cloud to play in this as former FERC chairman and your role now in GridPolicy? Is there a role for cloud to bring in this data, or how are things? What do you think things will kind of pan out in this journey towards net zero carbon?
Jon, not only do I see a role, but I think it's essential. I think companies like Microsoft and the others that are in this space, need to get in this space. And another thing Arun talked about was, the underlying utilities, their model needs to change. Well, we need to change it in a way that we can provide for the competitive services of providing this data hosting and data transference and utilization, and the data has to be open. In other words, the data has to be consumers' data. The consumer has to have the right to be able to utilize that data any way they want to. It can't be held by monopolies. It can't be held by these third-party utilities. It has to be in the control ultimately of the consumer, and then ultimately it has to be able to be placed in the cloud and utilized in the cloud and utilized by anybody that the consumer chooses to use that. So I think there is a huge need to have these kinds of services put together, these platforms developed, and the platforms have to be ultimately across utility territories. That's why, again, I think we need to break up these current monopolies that we have, and we need to ensure that we have market structures, competitive market structures available to consumers to utilize and have access to this data and access to the data not only to the consumers but to the service providers to the consumers who are helping them get the value for these resources behind the meter that I talked about earlier.
Yeah, we've heard the terms of data being the new oil, is the new source of energy. And anyway, so we're out of time, and I really appreciate you, all you panel members, coming here and really sharing your time with us and your thoughts. I'll just wrap it up. If you have some last closing comments, we can just go quickly around the horn. And Arun, we can start with you if you'd like to have any closing comments.
Well, I just want to, again, end by saying thanks to Microsoft for your leadership. I think it's very important that you address this internally, but I think it's even more important to create value for other entities, individuals, people. And because this is a global issue which will involve the 10 billion people on this earth by 2050. And so I think the role of Microsoft and other organizations cannot be underestimated. So this is going to be a huge transformation, and I think if there's a value that is created, there's probably a business opportunity, but I'll leave it up to you guys to figure out how that goes. But I think there's tremendous value in what you're doing and what you're starting off, and I think that value is not just internal to Microsoft, but for the rest of the world as well.
Great. Stan.
Yeah, I was going to say these are very exciting times. Clearly, it's good times for the researcher. But as Arun said, we have to find ways where the utilities can still make money as we cut back on our energy usage. But I think we all have to worry about sustainability as well as just energy usage. We've got to make our lithium batteries or our electricity in a much more sustainable manner. But these are certainly exciting times for all of us.
Great. And Jon.
Well, Jon, again, I do want to thank Microsoft for putting this great panel together, and it was great to share it with these two gentlemen that have incredible credentials. And I would say, in closing, that we really do need to look at this issue of markets. I believe that markets can be very powerful drivers for us moving towards a decarbonized society. I believe the monopolies need to step out of the way. We need to allow companies like Microsoft and others who have the experience in these competitive areas to ensure that they can put in place these kind of data platforms and other mechanisms that I think are going to be absolutely necessary to get to the transformation that we all hope we can achieve. And that is, decarbonizing our grid, decarbonizing our society, and addressing the global warming challenge that we have.
Great note to finish on. And I'll just say thank you for joining us again. And I hope our audience enjoys our this panel. It certainly was a pleasure for me to have moderate with the three of you. It's been my pleasure today. So thank you.